In this lecture, I am going to discussing the example problem on how to formulate the linear programming model problem. Let's see the problem. A person requires 10, 12 and 12 units of chemicals A, B and C respectively for his garden. A liquid product contains 5, 2 and 1 units of A, B and C respectively per jar. A dry product contains 1, 2 and 4 units of A, B, C per carton. If the liquid product is sold for 3 rupees per jar and the dry product is sold for 2 rupees per carton, how many units of each product should be purchased in order to minimize the cost and meet the requirements? Let's see the solution. First step is identify the decision variables. We know that decision variables are the products to be produced by a company. In the data, it is given that liquid products and dry products to be produced, but for the better clarification, we will go for the second step, that is identify the objective function. We know that objective of the any company is profit, cost, sales, etc. In the data, it is given that minimize the cost and also given the cost of the products, that is 3 rupees per jar for the liquid product and 2 rupees per carton for the dry product. Then the decision variables will become the number of units of the liquid product as well as the number of units of the dry product. And also, since the cost for the products are given, that is we have to minimize the cost. Then objective function will become the minimize Z equal to, that is minimize the cost, Z equal to 3 into number of units of liquid products plus 2 into number of units of dry products. Here number of units of the liquid products as well as the number of units of the dry products are the decision variables. So then the decision variables, let's consider x1 equal to the number of units of the liquid products and x2 is the number of units of the dry products. Then objective function will become the minimum cost, that is Z equal to 3x1 plus 2x2. Next step is identify the constraints. For this, observe the data, that is a person requires 10, 12 and 12 units of chemicals A, B and C respectively for his garden. So here requirement is there for the different chemicals, that is the chemical A and B and C. So we have the constraints are there for the requirement of the different chemicals. Then we have to write the constraints for each chemical point of view. Moreover, it is given the a liquid product contains 5, 2 and 1 units of chemical A, B and C. Similarly, dry product contains 1, 2 and 4 units of the A, B, C chemicals. So as there are 3 chemicals and their requirements are given, we have the 3 constraints for these 3 chemicals. Then first we have to see the constraints for each chemical point of view. First constraint is the chemical A point of view. So chemical A requirement is 10 units and a liquid product contains 5 units and a dry product contains 1 unit. Then the constraint is the chemical A point of view 5x1 plus x2 greater than or equal to the 10. Next we have to see the another constraint in the chemical B point of view. Here chemical B point of view requirement is 12 units and liquid product contains 2 units and dry product contains 2 units. So constraint in the chemical B point of view 2x1 plus 2x2 greater than or equal to the 12. Similarly, chemical C point of view requirement is the 12 units and for the liquid product 1 unit and 4 units for the dry product. So constraint is the chemical C point of view x1 plus 4x2 greater than or equal to the 12. So for this one given the LP model problem, so formulation of the LP model is the objective function, that is the z equal to 3x1 plus 2x2, and subjected to constraints are the 5x1 plus x2 greater than or equal to 10, 2x1 plus 2x2 greater than or equal to 12, and x1 plus 4x2 greater than or equal to 12, and x1 comma x2 are the greater than or equal to the 0. So this is the solution, and thank you.